Flame tests can be used to determine the identity of metal ions in a solution or a solid. Lunch Leave Chemistry is going to explain how this works.
When we view salts, we tend to visualize cations and anions floating around in solution, along with the water of course. However, identifying unknown cations in aqueous solutions tends to be problematic, as most are colorless in solution, with the exception of iron 2, iron 3 and copper ions. If these solutions are put through a flame test, many metal cations produce characteristic colors when they're subjected to a blue Bunsen flame. Just think about fireworks. Anyways, the reason for this lies in the electron shell structure of the atom. When a metal salt is vaporized in a flame, the outer shell electrons of the metal ion may absorb energy and move to a higher excited energy level. Excited electrons are unstable, and as they fall back to lower levels, they emit light of various characteristic frequencies. Some of these frequencies correspond to the visible region of the electromagnetic spectrum. We see the result of the emission of these colored photons. In fact, the color emitted by the larger atoms is lower in energy than the light emitted by smaller ions. So, for example, strontium, atomic number 38, gives a reddish color as compared to the yellow color of sodium, atomic number 11. The sodium ion has greater affinity for the valence electron, so more energy is required to move that electron. When it does move, it goes to a higher excited state. As the electron descends to the ground state, it has more energy to disperse, which means the color has a higher frequency / shorter wavelength. But what about the anion, you ask? Well, we generally use chloride salts in which chloride's valence electrons are strongly held to the nucleus because of the high electronegativity. It is possible to excite these valence electrons, but as they descend back to the ground state, the emission spectrum is generally outside our visible range, so don't contribute to the flame color.